Before we start the show, don't forget to check our new ebook, Kill All Bugs, Learn Software Testing in One Day. For a limited time, it's only $9.99. Links in description.
Okay, let's get into it. Have you ever stopped to think about what's happening behind the scenes when you use an app? Or maybe your online banking?
Yeah, like how different bits of software actually talk to each other, especially when they might be written in totally different programming languages.
Exactly. How do they manage that conversation smoothly? Today, we're diving deep into a tool called SoapUI. Specifically, how it helps create test suites and test cases. These are designed to make sure those background conversations are always, clear and correct.
Right.
We've got some great source material that walks us through testing web services using a simple online calculator example.
It sounds basic, but it's a perfect illustration.
Our mission here is to really unpack the core ideas and the practical steps involved. It's pretty essential stuff for software reliability today.
And what's really cool, I think, is that we're looking at the absolute foundation of how all these interconnected systems work reliably. It's fundamental.
It's more than just finding bugs then.
Oh, absolutely. It's about checking the language they speak, the rules they follow. It's verifying that whole interaction. That's what ensures when you, say, click add, you actually get the right answer.
Or when you transfer money, it goes to the right place.
Precisely. And SoapUI helps automate what would otherwise be an incredibly tedious manual process. Painstaking, really.
Okay, so to really get SoapUI, we probably need to start with the basics. The communication protocol itself, SOAP, especially for older systems, right?
Yeah, SOAP. Simple Object Access Protocol. It's basically an XML-based way for different systems to chat.
XML-based. And the key thing is, it doesn't matter what language or platform they're built on.
That's the beauty of it. Platform and language independent. So yeah, a Java system can talk to a .NET system, no problem. Think of it like a universal translator for software.
A universal translator. I like that. And these SOAP messages, the requests and responses, how do they actually travel?
Typically over HTTP, the same protocol your web browser uses every day.
Ah, okay. So it's using the web's existing infrastructure.
Exactly. It leverages that common ground. The message itself, whether it's asking the service to do something or sending back the result, is just an XML document.
Just an XML document. Why XML specifically? What makes that format good for this?
Structure. XML gives you a really organized, hierarchical way to lay out the information.
So it's predictable.
Totally predictable. It defines exactly what data is being sent, how it's formatted. For machines talking to machines, that clarity is vital. There's no ambiguity. It's like a really detailed instruction manual for the data.
Got it. Okay, so that's SOAP, the language. Now, let's get practical. Setting things up in SoapUI. The source material talks about creating a project first.
That's the starting point. Yeah, you create a new SOAP project.
Yeah.
And the key input here is the WSDL URL.
WSDL, Web Services Description Language.
You got it. The WSDL is like the service's blueprint. It tells SoapUI everything, what operations it can do, like add or subtract in our calculator example.
What kind of data it needs, what the response looks like.
Exactly. It's the whole architectural drawing. For our example, we use a public URL. http://www.dneonline.com, calculator.asmx.wsdl.
And when you plug that WSDL into SoapUI, it does some work for you, right? Like importing operations.
Yeah, it usually offers to create sample requests for all the operations it finds in the WSDL. That's often checked by default.
Handy.
Very. It can also set up a test suite for you right then and there and manage relative file paths. It really streamlines the setup.
So for the calculator, you'd instantly see things like add, subtract pop up in the project.
Yep. Ready to test.
Yeah.
Which brings us to the quick manual check.
Right. You can just send a request straight away.
You can. You find an operation, say add, open its request, maybe plug in 5 and 5 into the XML where it asks for int A and int B.
Manually type them in.
Yeah, just edit the XML placeholders, and you hit the submit button.
And you see the response, like 10.
Exactly.
Right.
You see the response XML on the right side. It's great for that first quick sanity check. Is this thing even working?
Okay, that sounds easy enough, but why bother with test suites and cases if you can just do that?
The why test cases moment. Because doing it manually for one simple request is fine. But imagine you have 10 operations. Or you need to test add with 50 different pairs of numbers.
Great. Editing that XML manually 50 times.
Or 100 times. It's just not practical. It doesn't scale. That's the wall you hit very, very quickly.
So that's the bottleneck that test suites and cases are designed to break through, automation.
Precisely. They move you from those one-off manual pokes to a structured, repeatable, automated way of testing all the scenarios you care about. It's a fundamental shift.
Okay, let's build that structure then. First up, the test suite. How does that work?
Super simple. You just right-click on the root of your project in SoapUI, choose New Test Suite,
Doom it didn't name.
give it a sensible name, click OK, and boom, it appears in your project navigator.
And if you open it up,
Initially, it's empty. It shows 0 test cases. All the options related to running tests will be grayed out because, well, there's nothing to run yet. It's just a container.
a folder for your tests, essentially.
Yeah, a logical grouping.
Yeah.
Very useful for organizing tests, maybe by feature or by type of test.
So, container created. Next, we need to put something in it. The test case.
Right. You right-click on your new test suite. This time, choose New Test Case.
Give that a name, too.
Yep. Specify the name, click OK. Now you have a test case inside your suite. And again, initially it has 0 steps.
I see. And the source mentions numbers in brackets next to things like test steps, load test.
Yeah, those are counters. They just automatically update as you add things.
Yeah.
So when you add your first test step, that test step 0 will change to test steps 1.
Okay. So how do we add that first step, let's say for our SOAP calculator?
You right-click on test steps within your test case. You get a menu of different step types. You'd pick SOP request for this.
Makes sense. What happens then?
You give the step a name, click OK. Then a dialog pops up asking you to choose the specific operation you want this step to call.
From the WSDL we imported earlier.
Exactly. It lists the available operations. You might see different versions, like Calculator SOAP, which uses SOP 1.1, and Calculator SOAP 12 using SOAP 1.2.
Does the version matter much here?
For this basic example, not really. You just pick one, maybe the add operation, and click OK.
And then it asks about assertions. You mentioned those earlier.
It does. Assertions are crucial for real testing. There are the checks. Does the response contain the right value? Is the XML valid? Is there an error?
But for this first walkthrough, we're skipping them.
Yeah, the source material has us create this step without adding assertions for now, just to show the basic request-response flow first. We'll add validation later.
So you click OK.
And bang, the XML request for the add operation appears in the step editor window, and your test steps counter clicks up to 1.
Okay, so now we have a test case with one step, which is a SOAP request ready to be sent. How do we actually run this version of the request?
It's very similar to the manual one we discussed, but now it's inside our structured test case. You see the request XML again. You find the placeholders, those question marks for NTA and NDT.
And put in our numbers, like 5 and 5 again.
Yep, type 5 and 5.
Yeah.
Then there's a submit request button right there in the step editor. Click that.
And you should see the response.
You should see the SOP response from the web service appear in the response pane, showing the result, hopefully 10. Confirmation again.
Okay, standard stuff. But you mentioned getting behind the curtain, seeing the raw communication.
Ah, yes, the raw tabs.
Mm-hmm.
This is where you see the HTTP stuff. Remember, SOP rides on HTTP.
Right.
So in the SOP request window for your test step, click the raw tab. What you'll see is the actual HTTP PST request that SoapUI sent. It shows the headers, the target URL, and crucially, your SOP XML message embedded inside the HTTP body.
Like seeing the envelope and the letter inside.
Exactly. And then, in the SOP response window, click its raw tab. You'll see the HTTP response that came back from the server.
And hopefully a 200 OK status code.
That's what you want to see for success. HTTP code 200 means the server received the request, understood it, and processed it successfully. The SOAP response XML with the answer will be in the body of that HTTP message.
That seems incredibly useful for debugging if things go wrong.
Oh, it's essential. If you get a response, but it's not what you expect, the raw view is often the first place to look. Did the request go out correctly? Did the server respond with an error code?
You mentioned error codes, like
Yeah.
404, 500.
Yeah, quick rundown. 2XX codes like 200 mean success. 4IX codes like 400 bad request or 404 not found usually mean the problem is with the client's request, something you said was wrong.
My fault.
Right. 5X codes like 500 internal server error usually mean the server itself had a problem trying to process your valid request. Its fault.
Okay, that helps narrow things down fast.
Definitely.
Oh.
The raw view also shows other details like HTTP headers, cookies, attachments, things that can be vital for more complex scenarios. I remember chasing a bug once where the raw view showed a tiny header mismatch causing the whole thing to fail. Saved me hours.
Wow. Okay, besides the raw view, there are also logs.
Yep, SoapUI has dedicated log panes at the bottom usually. They provide even more detailed transaction info.
Which ones are most useful?
Well, the SoapUI log gives you general response info from the server. It also gets saved to a SoapUI.log file, so you have a history.
Okay.
The HTTP log basically mirrors what you see in the raw tabs. It shows all the HTTP traffic back and forth, useful for scrolling through a sequence of interactions.
And errors?
There's an error log. That's your go-to when things break. It logs any errors SoapUI encounters during your session. Super helpful for diagnostics. It saves to SoapUI-errors.log.
Good to know. Any others?
There's also a memory log. It shows a chart of memory usage. Probably not something you'll look at all the time, but if you're doing performance testing or dealing with huge messages, it can be useful to monitor for issues.
So between the response pane, the raw view, and the logs, you get a pretty complete picture of what happened.
Absolutely.
Yeah.
You see the result, you see the underlying transport, and you see any errors or detailed logs. The next logical step, of course, would be adding those assertions we skipped earlier to automatically validate the response. But that's maybe for another time.
Right. Okay, so let's pull this together. What does this journey through SOAP and SoapUI really mean for, someone listening?
Well, we've gone from the basic language at SOAP that lets different systems talk.
The universal translator.
Right. All the way to building organized automated tests using test suites and cases in SoapUI. You can see how this moves you way beyond just clicking a button once.
It's about building a repeatable, reliable process.
Exactly. Ensuring that complex applications, the ones we rely on every day, actually work correctly every single time, even as they change and evolve. It's that hidden layer of quality control.
That invisible infrastructure, as you called it earlier.
Yeah. And if you think about the big picture, almost every digital interaction you have relies on something like this working flawlessly behind the scenes. Checking your bank balance, booking a flight, streaming a show.
It all depends on services talking correctly.
It does. Which kind of leads to a final thought, maybe. Think about just how much you depend on these digital systems daily. What would your day look like if this kind of rigorous testing didn't happen?
Chaos, probably.
Maybe. What parts of your digital life would feel the impact most if web services suddenly became unreliable? What complex interactions are happening that you just take for granted, assuming they'll always work because, well, someone, somewhere tested them thoroughly?
Hey, yo, haven't you checked out our new book yet? Link in description.